Good morning, everyone. So yesterday, what we have seen, what we did, given a context-free grammar, we have learned how to construct a push-down automata. Okay. So today, what we're going to see is we'll be seeing the reverse of it. Mhm. So we'll be seeing the reverse of it. So regarding this reversing, reversing means given a push-down automata, you have to construct the context-free grammar from that one. So for this one, right, uh, I need to write the rules first. Let me write the rules clearly. And then using those rules, right, we'll be constructing the context-free grammar. So let me write the rules first, okay? And then once again, whatever I've explained in the class, please go back and go through once. And then I'm quite occupied till this week. By later next week, right, I'll be giving you out your score. After that, I'll be conducting series of tests again, okay? So now let me write the rules first. Woohoo. So today's topic is construction of CFG from okay, or else in textbook you may find like construction of context equivalent of a PDA. It's almost now the given PDA, right? We're going to assume that that P Q this Q not. So let me, instead of this P, let me change it with MPDA because P I'm going to use for context-free grammar, what to say, production rules. So sometimes people are quite confused. So instead of representing push-down automata by capital P, let me represent by M, and then I'll write this PDA. M is representing machine, and the type of the machine is PDA. Okay, so this one, right? I didn't mention final set of states because we are considering that the push-down automata provided to us, right, will be a type of push-down automata which is going to accept the string by emptying this tag. That's why I'm not mentioning the set of final states. So let be the PDA that accepts a language held by empty stick. Empty stick. If suppose in exam, right, if I provide you a PDA which is of acceptance by reaching the final state, you just modify it a bit, which is going to accept the PDA by emptying the stack and then proceed it. Okay. Then let G is equal to MTPS. So P here is representing production rules. Now, it's not let. Let has to be somewhere up. So this one, right? So we say then G will be constructed using the following rules. Okay, so PGA is provided to us. Let me just write it inside the bracket. This is given to us. And then from this given PDA, we have to construct a context-free grammar. In order to construct this context-free grammar, we need to assume certain points. So we need to assume that one. So let me write we need to assume something. So let me write assumption. Assumption. Let dollar be the stack bottom symbol. Bottom symbol. What do we mean by stack bottom symbol? Means when we are popping out something after popping out few terminals from the stack, and then if you're reaching this dollar symbol, then you can consider that no more terminals are present here. It's almost done. All the pop out of all the terminals from the stacks are already done. That's why we are reaching the bottom stack symbol. Okay, that's the meaning of this dollar symbol. And then another assumption is let S be the start symbol. Let S be the start symbol of the grammar. Because every grammar required start symbol S, so that's why we are assuming this one. Now, again, when we are constructing a grammar, right, production rules is the main backbone of a given grammar. So next rules to be written, right, it's nothing but how to construct a production rules from a given transition function of the transition function from the provided PDA to us, okay? So number one, right, it might be confusing, but let me write the rules first, and then while applying the rules, let me this is don't worry. Now this is Q will set of capital states. At production as Q naught dollar symbol QI in P. Okay. For all Q, I mean all the states present inside this set of states, at a productions, this S in non-terminal, and then Q naught dollar QI. So this inside this first bracket, inside this bracket, right, inside this square bracket, whatever is containing, right, as a whole, we are going to consider as a non-terminal. Okay, whatever we have written inside this square bracket, we are going to consider as a non-terminal in the production of the context-free grammar. This is rule number one. And then in the rule number one, I need to specify something here. I represents n number of states. N number of states. Sometimes push-down automata, which is provided to us, might be having 5 number of states, might be having 6 number of states, might be having 10 number of states. So for all that states, we have to mention this. Okay. So next one is number 2. For all Q, comma R, R is also a state, Q, and then A belongs to summation union epsilon, and then capital X belongs to capital X belongs to this text symbol. Then let me stuck with this. Okay, so capital X belongs to stack symbol. Then if this transition function, okay, A, then this is equal to R epsilon. If you find such kind of transition function in the given push-down automata, then at a production QXR replaceable by A in P. Okay, don't worry. I'm just writing the rules. Whenever I'm going to apply these things, I'll be recollecting this one. Okay. This is rule number 2. Then next one is rule number 3. Rule number, for all Q comma R belongs to this, A belongs to, A means terminal, okay? Terminal including epsilon, and that's why we are, and then X belongs to X symbol. If these are all transition functions. I don't know what happens. Q comma A comma X equal to is equal to R comma X1 X2 Xk, where X1 X2 Xk belongs to this, then for every Q2 at the reduction X Q this A R X1 Q1 Q1 X2 Q2 Qk minus 1 Xk Qk in P. Okay, it might be, you might be thinking that it's so confusing. Don't worry. Okay, I've just written the rules. Let me take the example, and then whenever I'm constructing production rules from the given transition function, which is a part of the push-down automata, I'll just recall the rules and then I'll explain the rules accordingly. Okay. So our target for today's class is push-down automata will be provided to us. Whatever the push-down automata being provided to us, we are assuming this one as it's going to accept the language by emptying the stack. From this push-down automata, we are going to construct a context-free grammar. In order to construct the context-free grammar, right, the main backbone of the context-free grammar is the production rule. And then before we proceed, how to construct a production rule from the given transition function of the given push-down automata, we are assuming two things. First one is dollar symbol as the stack bottom symbol, and then S as the stack start symbol. Okay, this S as the start symbol of the grammar, because every grammar needs a start symbol, like how we need an initial state in the case of machine. So that's why we are assuming S as the start symbol of the grammar. And then rest, Roman number 1, 2, and 3 are the rules for constructing a production rule from a given transition function of the push-down automata. So let me take one example. Cancel this. Convert the following PDA into equivalent CFG. Okay, for this PDA, right, let me just write the transition function like this. Q naught comma A comma Z naught, Q naught comma Z1 Z0 delta Q naught comma A comma Z1 Q naught comma Z1 Z1. Number 3 delta Q naught comma B comma Z1 Q1 epsilon. Number 4 delta Q1 B Z1 Q1 epsilon. Number 5 delta Q1 B Z0 Q1 Z2 Z0. Number 6 delta Q1 B Z2 Q1 delta Q2. Number 8 delta Q2 Z2 Q2 epsilon. Number 9 delta Q2 epsilon Z0 epsilon. See, this is the PDA provided to us. From this PDA, right, we have to construct the equivalent CFG. Now, as per the rules which I have mentioned here, right, with this particular rule, what was my type of PDA which I've assumed was that the string or the language is going to be accepted by this PDA, right? It has to be accepted by empty in the stack. So when I check the transition function of the given PDA, right, 7, 8, 9 is showing popping out of all the what stack symbol from the state. So that's why this this transition function. Hence, this is in that type. So no need to modify anything. Once we have this one, then we can proceed with the rules. Okay. So now before I proceed that rules, right? So I need to know how many states are present in the given push-down automata. So let me just scan the states, number of states. Q naught is there, Q1 is there, Q2 is there. So Q naught, Q1, Q2 are there. So let me just write Q naught, Q1, Q2. So number of states is equal to 3. And then as per the rules I have written in here, right, if you're going to construct a CFG for a given PDA, you need to assume the start symbol of the grammar. S be the start symbol of the grammar. So likewise, let me do it. Let S be the start symbol of the required CFG. Okay, I'm assuming the start symbol of the required CFG. And then I need to select stack bottom symbol. Okay, I need to select stack bottom symbol. So in my push down automata, right, there are 3 stack symbol, I guess. Z0, Z1, then Z2. So out of these 3, you can select anyone. So let me just select Z0 by default. So let jet not be the stack bottom symbol. Okay. Now, after doing all the pre-required assumption and all right, I'm going to start what to say constructing the production rules of the required context-free grammar. So now, okay. So as per the rules, right? As per the rules number one, for all Q belongs to capital Q. So in our case, how many states are there? In our case, how many states are there? Q0, Q1, Q2. So as per the rules, the first production rules has to be S replaceable by Q0 dollar QI. In this case, QI is representing all the states provided to us in the push-down automata. And then dollar in this case, it is nothing but what? Stake bottom symbol. So in our case, I have assumed jet not as the stake bottom symbol. So let me start inserting this format. Okay, let me just start inserting this one as the first production rules of our required CFG. So this has to be S replaceable by Q naught. In our case, dollar symbol is jet naught. This is one, Q naught, Q2. So as per rule number one, I have to insert production rules of this link rule number one. Okay. Now, next one is next. Let's say right. Transition of this format. This is Q, and then this is terminal capital X, and then this is next transition state R. From Q, we are moving to R, and then whatever the stake symbol, stake pointer you're pointing, the stake pointer is pointing towards capital X right now. It's popping this out. If you find the transition of this format, transition function of this format in the given PDA, then add a production rules of this format, QAR. No, not QAR. QXR here, replaceable by terminal A in the P, in production P. Now let me check what are the transition from the given push-down automata, which could be applied with this rule number 2. So now this transition number 3, 4, 7, 8, 9, they are applicable with rule number 2. They are applicable with rule number 2. So let me just write 3, 4, 7, 8, and 9 could be applied by rule number 2. Okay. Now this rule number 3. Let me write the transition function number 3 as like this. For this 3, right? Let me try to construct the corresponding production rules. So for this 3, right? Let me do something. Why it's not working? I don't know. Let me just rewrite it here. Let me rewrite transition function number 3 here. I'm rewriting transition function this Q naught B jet 1 Q1 epsilon. Now, as per rule number 2, this is QAX. Let me just use this one. This is QAX, and then this is R. Okay, if you have the transition of this format, then you have to insert QXR replaceable by A. Okay, so now in our case, what we need to insert is, Q in our case is represented by Q naught, X in our case is represented by Z1, R in our case is represented by Q1, and then A in our case is represented by terminal B. So this has to be inserted as one of the required production rules of the target context-free grammar. So let me insert this. Q naught Z1 Q naught Z1 Q1 replaceable by B. This is 3. The transition function number 3 has been changed to this one and inserted one of the production rules of the required context-free grammar using the rule number 2. Okay. Now again, what about this? This is Q1 B Z1 this. So in this case, right? This is Q A X R. For this one, Q1 Z1 Q1 replaceable by B. So let me write this particular transition function number 4 will be inserted as this type as the production rules in our target context-free grammar. So Q1 Z1 Q1. So let me write Q1 Z1 Q1 replaceable by B. This is also using rule number 2. This is transition function number 4. Now next one is 7. Now 7 also. This one is Q, this is A, this is X, this is R. So for this one, it will be Q1 Z2 Q2 replaceable by C. So let me write all these three in this format, and then later on I'll just copy and paste it. So for this case also, this has to be Q A X R. So this will be Q2 Z2 Q2 replaceable by C. And then for this one also, Q A X R. So this is equivalent to Q2 Z0 Q2 epsilon. So let me just write Q1 Q1 Q2 Q2. I'm bringing all these three here. Z2 Z2 Z0. Z2 Z2 Z0. Q2 Q2 Q2. Q2 Q2 replaceable by C, C, and epsilon. They are all using rule number 2. Okay, and then these are 7, 9, 7, 8, 9. Okay, so whatever the transition functions provided to us, out of those transition functions, right, we are checking out which are the rules applicable to this transition function and can be converted as part of the production rules of our target context-free grammar. So I'm ending the class here. I've got few works to be done. It's a request from my side. At least I expect few participation from you guys for Augury 2021, okay? Let me proceed tomorrow, because tomorrow I may cancel the class. I don't know, maybe, or else maybe I'll give the class in the afternoon or something. Tomorrow we have a small function at the college. tree plantation function at 10 a.m. Okay. Okay, fine. Bye.